the last thing we're going to do with quadratic functions is look at problem-solving situations where we can use quadratic functions to solve. And there's a lot of different situations that can be modeled by a quadratic function. I mean, anytime you throw something or something is launched, it always follows a parabolic pattern, the shape of a parabola. But that's not the only use, okay? There are other situations too where we can find the maximum of something or the minimum of something. And if we're finding maximum or minimum, graphically, that means a parabola. Okay? Because parabolas have maximum and minimum. So we're going to start with where you're given the function, okay? And you're given the situation and you're asked questions about the situation. We're then going to progress in the last lesson of this unit to creating these things. How do we set them up? This is kind of like in grade 9 when we did word problems using equations, okay, where you had to say, okay, let x equal this or let n equal this, and then you made your equation and then you solved it to find the answer. That's what we're going to be doing. We're going to be doing something similar with that. But let's just look at this example first, where you're given the quadratic function, okay? And just remember, these are quadratic functions. So that's why we use the function notation. This really just means the same thing as h. So on a forward dive, a diver's height, h meters, above the water is given by the quadratic function negative 4.9 t squared plus 6t plus 3, where t is the time in seconds after the diver leaves the board until he hits the water. Okay, so that's the situation. So instead of using y and x, we're in a problem-solving situation. So we're going to use h for y, for height of the diver, and we're going to use t for x, for time that the diver starts his dive and finishes the dive. So we're asked to find the y-intercept. So remember, think of this like it's y equals, and then this is x, and this is x. So really what we're finding is the h-intercept in this problem, which means the same thing as the y-intercept. How do we do that? What do? We make t, or x, like whenever we find the y-intercept, we make x equals 0, but because in this case we're finding the h-intercept, we make t equals 0, correct? So we get negative 4.9 times 0 squared plus 6 times 0 plus 3. What is that? 3. Because this whole thing becomes 0, this whole thing becomes 0, so I'm just left with a 3. However, now, because we're in a problem-solving situation, what does this 3 represent in the problem? Yes, it represents the height, but that's not enough of an explanation. The height is 3 when what? When time is 0. What does that mean in terms of the problem? Time is 0. What's happening? What's that? Right, so they're just leaving the board, which makes sense because the person, it has to be 3 meters above, it has to be above the water, right? So this means the diver is 3 meters above the water when he starts his dive. Which means, that means t is equal to 0 seconds. That's the starting. The next thing, I want to find the vertex. This would be, now remember, there's two ways you can find the vertex. You can complete the square and put it into vertex form, but do you see how nasty this would get? You'd have to factor out negative 4.9, so you'd have to divide this by negative 4.9. Yeah, exactly. Not great. Let's do the other way. What was the other way we found the vertex? We found the x vertex, or in this case, t, by doing negative b over 2a. And then when we got that answer, we plugged it in to find the y vertex, which, well, y in this case is h, and that gives us the vertex. So what is the value of b? 6. So it's going to be negative 6 divided 2 times negative 4.9. So that's going to give me a decimal. So we're going to have to do a decimal here. And when you do that, so what is that? 6 divided 9.8. That's going to give us a lengthy decimal. Let's just go to 2 decimal places. You get 0.61. Now I'm going to take that, plug it in for t to figure out the y vertex, or the h vertex. So negative 4.9 times 0.61 squared plus 6 times 0.61 plus 3. So obviously I'm going to have to use a calculator for this. Okay. And make sure I'm getting the right numbers. I get 0.61. Okay. So I'm going to do all this once. I have to square first. So 0.61 squared gives me an answer. Times that by negative 4.9. And I get negative 1.82329. Plus 6 times 0.6.61 times 6 is going to give me 3.66 plus 3. So I'm going to add these up, and then I'm going to round to 2 decimal places since I kept the other one at 2 decimal places. 2 decimal places is usually safe. No significant figures. Don't worry about that. I usually get that question. So negative 1.82329 plus 0.61 plus 3 gives me about 1.79. That's wrong. That's wrong.
You honestly think that's true.
Negative 1.8. Oops. Negative 1.82329 plus 3.66 plus 3. Yeah, 4.84. Yikes. 4.84. So that means that the vertex is 0.61, comma, 4.84, except you have to explain what each value represents. Remember, x is time, right? And what's the time here? In what, seconds? Yes, seconds. So this is 0.1 seconds. Y is the height in meters. So this is 4.84 meters. But you've got to explain it. What does this mean, Lilia? Okay, but what does this specific one mean? This point. What's happening at this point? At the highest, right? At the maximum. And how long did it take to get to the maximum?
0.61 seconds.
Right, 0.61 seconds. Did you want to?
That's what I'm with.
Okay. So the diver reaches the maximum height of 4.84 meters after 0.61 seconds. That's explaining it. Okay. I know a lot of times in math, all we do is calculate the final answer and move on. Sometimes put units in. But this is more interpreting. This is kind of like what statistics is about. Not just calculating values, but also interpreting what they mean. Okay. So you have to interpret what the y-intercept is. You have to interpret what the vertex means. Okay, so if we actually graphed it, it would look like this. Notice, in a regular parabola, we have arrows going down, right? And does it make sense that it's going down, that there's a maximum? Why? Yeah, because in the equation of the function, it's negative 4.9 x squared. But notice I don't put in this section, because that doesn't make sense to have it as part of the problem. Why? Because this is negative time. So that doesn't make sense. It has to start here. And technically, it should end here when he hits the water. Yes, it could continue for a little, it could go for a little lower, depending on how deep the pool is. But there's no arrow, is there? There's no arrows here. It has, the dive has a starting point and a stopping point. There's no continuation. So looking at this, approximately when does the diver hit the water? This is being able to read a graph. It's going to be here at 1.6. Okay. So approximately 1.6, what are the units? Seconds. Don't get your units confused. Where is this point? 0.61, comma 4.84. Yeah, it's here. Right there. Just, that's the max. So that this we actually calculated. 0.61. I know you weren't asked that. But we do need this information to help us answer the next question. What is the domain and range in this specific situation? So remember, it's not going on forever. There's no arrows in this, so you got to be careful how you write your domain and range. Your domain and range is still furthest x value to the left, comma, furthest x value to the right. What's the furthest x value to the left? 0. And to the right, we said approximately 1.6, and we include those. So that's our domain. And our range, lowest y value,
Wait, 0.
0. Highest y value,
4.8.
right, 0 to 4. There we go. having flashbacks of physics? No? Okay. Don't you do this kind of stuff? Kind of. I said kind of. Okay.